Welcome back to our third video of writing an MNIST classifier from scratch. In this video, we're going to define the training loop. In the previous videos, we went through importing the packages and defining the model class, as well as defining hyperparameters, device, model, optimizer, loss function. We also downloaded the MNIST data and defined the data loader. The training loop is an iterative process in which the model gets trained by the training dataset. Since it is an iterative process, it makes sense to start writing of it by using a for loop. And each iteration of the training loop is historically called an epoch, so I'm going to use the same terminology here. For epoch in range of my hyperparameter num epochs, now each epoch is going to be one iteration of the training, but within each epoch we need to define another loop, and that is looping through the mini batches of the data. So for batch index and x and y in enumerate of train loader, and remember, train loader was a data loader that was defined on the training dataset. It will give us the mini batches of x and y, and with the help of enumerate, we're also getting the batch index. X is the mini batch of images, and y is the labels of those images that are in the mini batch. So now, in writing the training loop, there are 4 steps, 4 pieces that we definitely need to define. I want you to think systematically about these 4 pieces, and every time you're writing a training loop, you need to put placeholders for those 4 items. We might have some other items as well, but in the absence of those other items, we always have to do something about these 4 items. So these are must items, basically. Let's just leave some comments to make sure that we are going to touch base all of them. The first one is send the data to the device. The second one is to prepare the data for the model. Remember, like in our example, we need to flatten the images before entering them to the model. That is going to happen here. Next is forward propagation, which is introducing the data to the model and getting a prediction for every single image. And next will be backward. In the backward propagation, we will calculate loss from the prediction and the actual labels, and then we will use the optimizer to update the weights and biases of the model. So let's write codes for each of these. Sending the data to the device is very simple. X is x dot to device, and the same for y. Y is y dot to device. So this part was simple. In this case, depending on what example or what kind of model you're developing, you might do a lot of different things. In our case, we know that we have to just flatten the images. So x is equal to x dot reshape -1 and 784. 784 again comes from the fact that each image is a 28 by 28 image, and 28 by 28 is 784. For the forward propagation, we need to do 2 things. First thing is to pass the model through the model, pass the data through the model and get y hat. And y hat is the prediction of the label of every single image. Y hat is model of x. Next, use the y hat to calculate the loss. Loss is going to be equal to criterion of y hat and y. In the backward propagation, we always use 3 lines of codes. We first zero the gradients of all tensors. Optimizer.zeroGrad will do that for us. Remember, Pytorch tracks all the gradients that have been so far calculated for every single tensor. We don't want these gradients to accumulate. We want every one of them, for every epoch, we want them to be calculated separately. ZeroGrad will take care of this for us. Then we need the loss to go on the backward move, and we would need the optimizer to kick in for 1 epoch. At this point, we're good to go. If we run this code, our model should get trained for 5 number of epochs. The problem is, since we haven't written the check accuracy function yet, we're not going to be able to see the accuracy of the model. And conventionally, deep learning models are developed in a way that during the training process you get some updates. You get, for example, the accuracy of the model for every single epoch. And this keeps you updated because you don't want to wait 2 days, for example, for your model to get trained and you find out that something was wrong. You need to get some updates while the model gets trained. In this case, we don't have that much capability here. One thing we can do is to make sure at the end of each epoch, at least we get an update that this epoch is done. So let's just write an fs string to be printed that the epoch number is done, for example. One other thing we can report here is the loss, the value of the loss, because we know that the loss is being minimized. We're trying to minimize the loss. So if we report that, and if the trend shows a decay in the value of loss, it will give us some sense that the model is being trained in the right direction. So the way to do that, keep in mind this loss value that we have here is being calculated for every single mini batch. This is not representative of the loss of every single epoch. In order to do that, we need to define a running loss, and I'm going to define it as 0 for every single epoch at the beginning. And once the loss is calculated, I'm going to add the loss of that mini batch to the running loss. And here I'm going to report it. If I run this, we should see that the model gets trained, and each epoch will have a loss value. And I expect that epoch number 2 will have a lower loss. Exactly. So we can confirm right now that the loss is actually being minimized. That is an indication of the fact that our model is getting trained. But you can see that we cannot make that much of a judgment on whether the model is working properly or not, or like whether we're getting a good accuracy in our predictions or not, because we don't see the accuracy level. The only thing we know is that the model is working. So at this point, we're done with this video. We wrote the training loop. We touch-based 4 main items of every single training loop: sending the data to the device, prepare the data for the model, writing the forward propagation, and also writing the backward propagation. With the backward propagation, I want you to remember that we always repeat these 3 lines. Again, for each of these steps, we might add other things, depending on the data and the question and the type of model that we are developing. And for our training loop in general, we might have other pieces to add. But the systematic way of thinking about the training loop is that these 4 items definitely need to be written. So don't ever forget to include these 4 items. And also, as I showed to you, the calculation of accuracy is an important thing. So let's just go move on to the next video where we're going to calculate the accuracy. I'll see you there.